this video, I'm going to look at a Sony STR DE455. This is a multi-channel decoder surround system. It's a 5.1 channel. This is made a little before they came out with the HDMI. So this one here is just going to have your standard AV switching and digital input, coaxial and optical. It's got your 5-channel outputs, your rear, left, and right, your center, and the front. Very basic unit, just a 5-channel basic receiver with composite only video switching. Now the fault as claimed on this unit is that it cuts in and out. The sound cuts in and out. That's the claimed fault. There are a couple common problems on this unit, so we're going to take it apart and just do a visual inspection and see whether it's one of the common faults. So we'll remove the screws and take the top and bottom pieces off. What I'm looking for on this is bad solder connections, as there are some known issues on many of these Sonys, and a lot of problems with Sonys can be resolved by repairing the bad solder connections on some of the key components inside. Once the screws are removed, the back or top cover just lifts off. This was made after Sony went back to discrete parts. Sony, along with a lot of the other manufacturers, went to the STK amplifier module design, and that was a disaster for them. This one here has discrete transistors for the 5-channel, so there's 2 output transistors per channel all the way along the back here on this good size heatsink. The components that we are interested in are the voltage amplifier ICs. That's going to be these ones right here. We got to pull the bottom off it and inspect and check the connections on those ICs. These ones got quite hot and there was a lot of heat stresses. Also, the regulator, 3-terminal regulators, had a tendency for solder connections to fracture on them. So let's get the bottom off so we can look at that. So say this is one of these overrated units. Look at this little tiny transformer. At least it's got a real transformer in it and not a switching power supply, but you're not going to get a lot of power off a small transformer like this. This is one of these amps where they rated it big power, but in reality it didn't have nearly the amount of power that they claimed. Uh-oh, Houston, we have a small problem. Do you see the problem? No access panel. This is one of the later model Sonys where they moved away from having a separate cutaway access panel. So in order to work on this, we actually have to remove the circuit board, and that creates a much bigger headache as far as servicing. Now I'm faced with removing the screws for the heatsink and removing the board and removing the back panel to work on this. Creates a lot more work. This was when they were trying to make things cheaper. You know, how much cheaper could it make the manufacturing to not cut a panel in the bottom? If you've looked at some of my other videos where there is a panel in the bottom, you'll realize that it's one cut on a hydraulic press. They cut a pattern in the bottom with a series of tabs on it, and then the cover is rotated and the tabs line up with mounting holes. So if you took the bottom off it and rotated it, it would actually fit in the cutaway. So cost-wise, it's the cost of making one additional cut to the base, which made them very easy to service. This is something that was started by Yamaha. They started building them like this, and everybody else followed suit and just made these things. Maybe it was the plan, let's make them hard to service so nobody will service them and then they'll buy new, and maybe that was the whole reason they did it, but it was just a stupid design. Another point of failure on these is these screws that have got the metal grounding tabs like that on it. There's another one over on the front side of the board down here. Right, these ones with the grounding tabs. the screws can come loose and cause intermittent problems. That one's not overly tight, so that may be our problem right there. It's just loose grounds. But since this is my receiver now, and when I get rid of it, I'm going to be selling it, so I want to make sure that it's not going to come back and bite me for something I overlooked. So I'm going to pull the board out and check for the connections on those voltage amplifier ICs, because they do fail. So when we're disassembling the unit, we're going to take out the screws along the bottom here, and this is the last one here, and we're going to remove, of course we've already removed the 2 screws down through here, and there's 2 screws on the board here, and there's another 2 screws on the back here, and there's one more ground screw down here. And when you put those ground screws in, be sure you tighten them up. We're going to unplug the main power connector over here, and then I can lift the board up. And tip it out of the way. Okay, get a load of this. We're over here. Look down here. I got my hand on the IC on the other side, and you can see. There's our problem. You see that? Exactly what I thought was going to be the problem. Those ICs need to be resoldered. I reflow those ICs, and this sucker will be fixed. So I'm going to heat up the iron, get the soldering iron going. They're going to redo all these connections here. Exactly what I thought. You can look at how bad that is. That's a big problem. It's because of the heat, and probably because they used a lot of lead-free solder on these units. You get thermal expansion of dissimilar metals. Now, in the days of high lead content solder was a rather soft alloy. So as the copper leads from the components heated up and cooled down, the solder would flow with it. It was malleable. It would bend. It wasn't brittle like the lead-free crap that they've started putting on. The lead-free solder is really quite brittle by comparison, and it doesn't handle well the expansion and contraction of dissimilar metals. So what happens is the copper lead from the component expands at one rate, but the alloy, which is on lead-free solder, is typically made up of tin, maybe a little bit of copper, and sometimes a little bit of silver. But its expansion rate is different than that of pure copper. So it gets brittle. And with repeated heating and cooling, you end up with a fracture on these components that have a high temperature difference, typically power ICs. So we see a lot of failures caused by this type of problem on these units. Oh, that's bad. So let my iron warm up for a couple of minutes here, get it up to good working temperature, and then we're going to go and resolder this. And I think probably that's the only problem. I'll also take a look at the regulator transistors while I've got it apart, because those ones which are up here, they also could be problematic. Actually, they don't look too bad, the regulator ICs, but that's another problem spot that quite often happens on these, because again, they are another component that the temperature changes quite a bit between the running state and the off state. It's also noted that more problems occur with people that run their amps, for several hours and then shut them off and let them cool down, and then run them again for several hours. Instances where, say, an amplifier is being used in a business or something where it's never turned off and it's always running at this, constantly, the temperature doesn't fluctuate, they generally don't have the same type of issues. Again, it's thermal expansion. Looks like my good old roll of Kester 6040 solder is actually getting down to its last couple of turns on the roll here. I'm going to have to break down and buy another roll. I don't think I'll be getting any stuff as good as this. So this is ancient. This is like from the probably the 1980s. This roll. I don't even know if I can get 6040 solder anymore because of the lead content, right? So then I'll have to start working in this lead-free crap. Wonderful. Yep. That was just a bit of crud from the end of my iron there. Now, some of you may wonder why I didn't run this until it cut out. When I was given it, I was told what the symptom was, that it was cutting in and out. And the person who owned it bought a new one. So they just gave me this and said, here, I was going to recycle it, but you can have it for your projects. The reason I didn't run it until it cut out is because when the connection breaks, it can cause the outputs to fail, depending on how the connection breaks. And it can also cause the IC to fail. So I didn't want to create any more problems. I didn't want to cause any component failures. I knew the symptom, and I knew going into this thing probably what the problem was going to be, because I've had this problem many times in my career of working on this stuff. So I kind of was knowing what I was going to be going into when I got into this before I opened it up. I'm just going to do the regulators now, because you know that they're probably going to be, connections are going to be going bad on here. This one here's another one that's cracked. I can see it in the magnifying glass. This one's bad. And this one here. That's probably all that's wrong with this. I'm just going to go over this with magnifying glass. Okay, I found some more connections on here after redoing the ICs and the regulator. I found that the relays here also, if you see them right in here, these connections on the relays, these are the speaker relays. You can see that that one there is cracked all the way around, right there. So we're going to redo those connections on the relays. And then I think this unit is probably going to be ready to go back together. I've just been staring at this board for a few minutes here after redoing the other connections. And speaker relays are also a problem area, so be sure you do them all. Be sure you do both the relay contacts and the coil wires. Coil wires are the bottom ones down here. It's failure to do that, and you can have your front channel or your back channel speakers cutting in and out, or your center channel. And there's one more IC here that I just spotted right there that I got to do too. I just spotted that one. I think I've got them. Nope, still got a couple more up here. Okay, I think I got them all. Let's we'll put the unit back together. These grounding screws, the ones with the tabs on them, these are fairly important that you get those ones relatively tight. There's two of them, one on each side of the board, because failure to tighten them can cause intermittent problems, random intermittent problems. Don't forget to connect the power connector and the other connectors that you may have removed when servicing the unit. So we'll connect up our negative leads here and our left and right. Of course, we can't forget the antenna, right? There. That'll work. better work. Okay, power it up. And make sure the volume's not cranked up. Speakers are on. I want to select tuner. And I can figure out how to work this thing. That's not that one. Tuner. Tuner is here, and how do I tune the volume? Oh, tuning. Here we go. Okay, let's try the volume here. Sounds like it's working to me. Okay, I'm going to let this thing run for a bit here. But we know we got it. I should go put my royalty-free music on. Then I can play it. Okay, we'll select auxiliary. And we'll turn on the DAT machine. And these are some tapes, DAT tapes, that when we purchased our music, when we purchased our royalty-free content years ago, it came from the studio on DAT tape. So, there we go, a little better. Well, that's it, the stress test on this thing, and I forget how many songs is on this tape. Might only be 4. I forget how many tracks we were on this. This is commercial music that my production company years ago, we're talking 15 years ago, we bought a library when we were in the business, and we needed music that could be put on, corporate videos and weddings and anything else that we needed. So we bought a library of music, and this stuff was really quite expensive, but it's licensed, so I don't get popped for copyright, because it's all licensed. I have the license for this through Music Bakery, or my company did, my former company. Anyway, this amp is working, so I hope you enjoyed this video, and we will catch you in the next one. Bye for now.